Okay.
Good afternoon. I'm Israel Hodges Jr. I've been a board certified environmental engineer for 3 years, and I'm currently serving on the Academy's membership committee. It is my privilege to serve today as the Master of Ceremonies for the 52nd Annual Awards for Environmental Engineering and Science. The awards program celebrates and recognizes both people and projects for their leadership in the continuum of more than 190 years of environmental engineering and science innovation and quality service. At this time, our president, Dr. Daniel Oerther, would like to say a few words and then introduce our keynote speaker, Dr. Glen Daigger. Dr. Oerther?
Thank you, Israel. I appreciate that. Hello and welcome to our annual celebration of excellence in environmental engineering and science, where we, the American Academy of Environmental Engineers and Scientists, recognize projects and celebrate leaders in our profession. My name is Dan Oerther, and it's my honor to serve as the president of our academy in 2022. As everyone is well aware, this year is special for our academy. We've emerged from the COVID pandemic positioned to make significant contributions to how we care for public welfare and promote planetary health. In the United States, more than 50,000 environmental engineers and more than 70,000 environmental scientists are hard at work, and our academy is at the forefront of these efforts. From the founding of our academy in 1955 through today, we've witnessed tremendous growth in the environmental movement. Our academy has grown from a registry of sanitary engineers created through a collaboration of the American Society of Civil Engineers and the American Public Health Association to a membership organization responsible for leading the ABET accreditation of nearly 100 programs of environmental engineering and science operating across the country and around the globe. We offer specialty certification to licensed professional engineers in diverse areas ranging from traditional topics such as water supply and wastewater engineering, hazardous waste management and site remediation, as well as air pollution, to more recent emerging areas such as environmental sustainability. We welcome experienced engineers who do not hold a license to be recognized as board certified members. And we offer board certification to environmental scientists in specialties such as biology, chemistry, toxicology, as well as groundwater and the subsurface environment. I'm particularly proud to be the first individual to have become board certified as an environmental engineer, as well as to have become board certified as an environmental scientist. And it is my pleasure to be the first board certified environmental scientist to serve in the role as president of our academy. Our academy has indeed grown a lot since 1955. In this year, in 2022, our profession celebrates the 50th anniversary of the Clean Water Act, a seminal piece of legislation, which is one part of a series of federal acts that help to transition the environmental movement from the passionate pursuit of a few dedicated professionals into the profession that we enjoy today. While we take time to celebrate today, we must remain vigilant to the challenges we face in the present, and we need to keep our eyes focused on the horizon where we face challenges in the future. In 2019, the National Academy of Engineering released an important report entitled Environmental Engineering for the 21st Century, Addressing Grand Challenges. With input from stakeholders from across the profession, the report identifies 5 areas where we have work to do. These include supplying food, water, and energy in a sustainable manner, curbing climate change and adapting to its impacts, designing a future without pollution or waste, creating efficient, healthy, resilient cities, and fostering informed decisions and actions. The report concludes with an important chapter entitled The Ultimate Challenge for Environmental Engineering, Preparing the Field to Address a New Future. Our academy is leading this effort as we refresh the body of knowledge for environmental engineering and consider the content for a new body of knowledge for environmental science. I'm honored to be co-leading this effort with Trustee Andy Shaw and a steering committee that includes established leaders in our field, such as John Kuhn and Deborah Reinhardt, as well as emerging leaders such as Colleen Naughton and Israel Hodges. We are seeking input from diverse stakeholders. We've authored a series of editorials appearing in a variety of journals to solicit input and advertise this process. I'm personally inviting you to join us as we refresh the environmental engineering body of knowledge. As I outlined to my fellow trustees in my presidential plan for 2022, my two chief goals include, number one, growing our membership through exciting activities such as webinars that will be free to members thanks to the financial support of sponsors, as well as growing recognition programs like our 40 Under 40 program announced today. Number two, ensuring the success of our new executive director, Ilyse Shapiro, as well as the smooth transition to the leadership of President-elect Dave Vaccari and Vice President Wendy Wert. We have a bright future in our executive directors and our future presidents. Today, we take time to recognize projects and celebrate leaders in our profession. In doing so, let us not forget to honor the legacy we've inherited from those who have come before us. Ours is a noble profession, and the environmental movement has never been more important for the future of humanity and our shared planet. Many talk of the current epoch, commonly known as the Anthropocene, a time when human activity is the dominant force for change on Earth. As the world's leaders in the environmental profession, we have the privilege and the responsibility to ensure that the change we see occur is in the best interest of those generations to come. To my colleagues and our friends of the Academy, welcome to today's celebration. To those who are being recognized, my heartfelt congratulations. We stand on the shoulders of giants, and today is an opportunity to recognize and celebrate those giants in our midst. Thank you, and welcome to the 2022 celebration of excellence in environmental engineering and science and our annual recognition of award winners. At this time, I'd like to introduce our keynote speaker, Dr. Glen Daigger. Glen and I have been personal friends for quite some time. In fact, the first time I learned about the Academy was when he had Diplomate of Environmental Engineering on a PowerPoint slide when he gave a presentation. Many of us know Glen, know of his history with CH2. Currently, Glen is a professor of engineering practice at the University of Michigan. We all know that he is an internationally recognized expert in wastewater treatment and water quality management for municipal and industrial systems. He has tremendous expertise in biological processes. We're honored to have Dr. Daigger here with us today. Glen, the stage is yours. Thank you for joining us.
So thank you so much, Dan. That was, first of all, your overall presentation of the Academy was outstanding. And thank you very much for the kind words and for asking me to speak here about the Clean Water Act. So Clean Water Act, of course, it's 1972. In 1972, I was a junior in civil engineering at Purdue University, just beginning to decide to then focus on this emerging specialty of environmental engineering. So it was an interesting time in retrospect because I came in at that point, but this was a period where environmental engineering was transforming from sanitary engineering, as you described, and the environmental engineering profession as we know it was really being formed. But I would submit, in fact, I would strenuously assert that the Clean Water Act is the most impactful piece of legislation relative to clean water, not only in the U.S. but internationally. And I had I took the time a few years to go back and read the act, and what I found was really a forward-looking and inspirational document, even by my perspective of several years, really a couple of decades already past its enactment and implementation. So what I really want to do is to kind of hit some of the important points, but really tie how the far-sighted nature of that document has been so influential, not only here in the U.S. but on a global basis. So the Clean Water Act, the formal name is the Federal Water Pollution Control Act of 1972. It wasn't the first. There was the Public Health Services Act of 1912, the Oil Pollution Act of 1924, the Federal Water Pollution Control Act of 1948, and a Water Quality Act of 1965. What was one of the seminal aspects, though, of the 1972 Act? One of the seminal aspects of it is that it established nationwide standards. Prior to this, it was judged that the states had the purview for water quality, and that some of these acts encouraged states but didn't require them. And it was viewed that the waters of the states were the business of the states. So some clever legislators said, how can we approach this? And navigation. The federal government has and had then the responsibility for managing navigation. So that was the basis. So this act applies to navigable waters. That's a controversial thing. In fact, the ongoing discussions and controversy and so forth about waters of the U.S. is really, what is the definition of navigable waters? And it says navigable and those affected by that. There's those that think that we don't go far enough. There are those that think we go too far in terms of that definition, but very clever. The objective of the act was to restore all of the navigable waters of the U.S. to a fishable and swimmable state. The goal was actually to eliminate discharges. And I think that was actually quite prescient and something that, as the profession, we've tended to push back on, I think, to our detriment. It applies to point sources, whether they be municipal or industrial, the two categories that were addressed first, to municipal non-point sources of pollutants into the waterways. But agriculture was excluded. Including agriculture was just a bridge too far in 1972, and it appears that it is in 2022. And that's an issue I'll touch on towards the end here. A fundamental concept was to establish uniform pollution control requirements that were enacted every place. And this was, in terms of implementation, was transformative. The idea, of course, is to eliminate pollution havens. If you wanted to develop your economy, be lax on environmental regulations was the idea, but no, we can't do that. So this leads to, for municipal treatment, secondary treatment as the technology requirement, for industries, for effluent guideline limitations, so uniform requirements for industry, and the definition of best available treatment, and the industrial pretreatment program, which has been so successful and so impactful in terms of controlling. And again, It was really the first large-scale effort of this type in the world, but it's been adopted around the world. This integrated approach is also something that's been adopted around the world. And for example, on the industrial side, the role of multinational corporations in terms of uniformly applying these standards has really made this into not just a US, but a national standard. The overall process involved these technology-based standards, that minimum that everyone needs to do, eliminating pollution havens. And then when that was insufficient, then water quality standards, quantitative water quality standards, the Gold Book was established, and each state had to adapt those as a minimum. And where that was not met, then additional controls of one type or the other were needed. This was related to designated uses, so fishing, swimming, water supply, and so forth, and put in place permitting requirements for the point sources and so forth to see that that these water quality objectives, that the intent anyway, that they would be achieved. Anti-degradation, also an important concept. If you look at the European Union in the late 80s issued the Urban Wastewater Treatment Directive, which is the moral equivalent of the technology standard throughout Europe. They followed that up a couple decades later with the Urban Water Directive, which is the water quality side of it. So you see how what the Clean Water Act did spawned the model that's used other places. There was an update in 1977, but the most significant one was the Water Quality Act of 1987 as an update. This formally recognized that we had waters that were not meeting these standards and established the 303D list, the list of impaired water bodies that we're still working on. It also formalized the stormwater regulations, the municipal separate storm sewer system regulations that are applied. So moving on to non-point source and agricultural point sources, which has been quite controversial, but at least as a step in terms of addressing agriculture. Out of this also came the total maximum daily load process, the TMDL process, again, which is emulated other places. What that involves is identifying the load that a water body can successfully process of a given pollutant, allocating that load to various contributors in the margin of safety. I've got a note here that says that there have been, first decade and a half, there were 60,000 TMDLs. But we're not done. The data are this, that about half of the streams and rivers, the flowing freshwater bodies, they're on that list. About 70% of lakes, ponds, reservoirs are not meeting criteria. About 90% of the ocean and the coastal zone. I think this just really represents, to a certain extent, the magnitude of the challenges that we have and are still dealing with. Funding, and this is really a misnomer. There are many that said, well, the federal government has funded so much of our water infrastructure. It is true that for about a decade and a half, the construction grants program provided significant funding, basically to ramp up the technology-based requirements, the secondary treatment. But even during that decade and a half period, it funded only about half of the spending, and it was an anomaly. So the the financial support for clean water is largely at the local level. The federal intervention was just a short time. The 1987 Act also set up the Clean Water State Revolving Funds, which are in place today. These are loans, not grants, as the earlier. Then one other I'll mention is the biosolids. The 503 regulations they were one of the first major risk-based sets of regulations, and of course applying to the residuals of wastewater treatment. We used to call it sludge. This created biosolids, and the idea that we need to control pathogens, we need to control chemical constituents, and put in place an approach, again, which is used worldwide. You can go to any country in the world, and they know what the biosolids regulations are. Some of the major successes beyond the items I've talked about here, toxics. In 1972, we had rivers that were burning. The Cuyahoga River, among others, which has been turned into folklore and songs. But so many toxics have been addressed. I think what's most important, though, is the idea of controlling pollution at its source and in a proactive fashion has been institutionalized. With all the pushback, we still do what is on the books, and it's been relatively uniformly implemented. We still have ongoing issues. Nutrients are certainly one of those. It's one which is proven to be very difficult to deal with, although we continue. And one of the issues there is that has not been resolved, but is whether we should establish numerical criteria for nutrients. That actually is happening at the state level in one way or the other, not at the national level, but it's happening. We hear about PFAS and so forth, but I would put this into a different category. I would characterize it as the ubiquitous presence of chemicals and the ubiquitous use of chemicals. PFAS is the one we talk about today, but we've had other chemicals in the past, and we'll have new chemicals. And wet weather, both certainly climate change is part of this, but it was a significant issue even before that. So we talk about things like sanitary sewer overflows and combined sewer overflows. We're going to be dealing with this probably forever within our profession. I will say that we need to also understand the difference between the legislation, which is the act itself, but the regulation. And I have to say that my own assessment is that we as a profession could have contributed more positively in terms of the regulatory side of this. Oftentimes we were pushing back when we shouldn't have pushed back. So in terms of, I think, a lesson learned going forward, that we should be more prepared to stand up for the environment rather than someone's pocketbook going forward. But seminal, transformative, written by a small group of legislators with, the aides are young people, but visionary, transformative, and still the basis for what we do in the wastewater management profession. So thank you very much for the opportunity to offer these thoughts. I hope I've generated some discussion that can occur, and I'll turn it back.
Thank you so much, Dr. Daigger. At this time, it's my pleasure to announce the winner of the Clean Water Act Award. The winner of this special award goes to Black and Beach and the Sacramento County Regional Sanitation District for their Regional San Echo Water BNR project. Back to you, Israel.
Thank you, Dr. Daigger, and congratulations to Black and Beach and the Sacramento County Regional Sanitation District. At this time, we will present the individual awards. The Honorary Member Award is awarded to a person that has attained a position of eminence in the field of environmental and/or human health protection, has made a single noteworthy contribution to the advancement of environmental and/or human health protection, or has rendered outstanding service over a long period of time, resulting in the advancement of environmental and/or human health protection. The 2022 Honorary Member Award goes to Carl Axel Soderberg. Mr. Soderberg is a graduate from the Georgia Institute of Technology with a bachelor's degree in engineering. He has a professional engineer's license from the Commonwealth of Puerto Rico. Mr. Soderberg is a member of the Institute of Environmental Engineers of Puerto Rico, the Association of Professional Engineers and Surveyors of Puerto Rico, the Inter-American Association of Sanitary and Environmental Engineering, and the Caribbean Water and Wastewater Association. Mr. Soderberg has 45 years of experience in the environmental protection field. He is currently serving as an advisor to the president of the Inter-American Association of Sanitary and Environmental Engineering, or IDES for short, and director of IDES Puerto Rico. Mr. Soderberg has given keynote addresses on environmental matters in 20 countries of Latin America and the Caribbean. He is the author of 2 chapters of the book, Themes on Sanitary and Environmental Engineering, the Vision of Experts from Latin America and the Caribbean. The book was published by IDES in 2014. He is currently drafting 2 chapters for an IDES book on water reuse in Latin America and the Caribbean. Congratulations, Mr. Soderberg. Next, we have the E4 Award. The Excellence in Environmental Engineering and Science Education Award is granted to an educator who has made a significant contribution to the profession in the area of educating practitioners. The E4 Award was established in 2012 and is jointly administered by AAEES and AEESP. The 2022 recipient is Dr. Chad Jaffer. Chad received his Ph.D. from the University of Iowa in 1985 and was awarded an NRC postdoctoral fellowship to work at the U.S. EPA Research Laboratory in Athens, Georgia. Dr. Jaffer's primary research interests are the chemical and physiochemical fate processes of anthropogenic substances in natural and engineered environments. Congratulations, Chad. The W. Wesley Eckenfelder Graduate Research Award is given annually to recognize an environmental engineering or environmental science graduate student whose research contributes to the knowledge pool of wastewater management. The award selection will be based on original, innovative research, of publishable quality, and other factors. The W. Wesley Eckenfelder Graduate Research Award was established in 2012 and is jointly administered by the Academy as well as AEESP. The 2022 recipient is Duong Tong Nguyen. Duong is a University of Colorado Boulder Environmental Engineering Graduate Associate. He is studying ultra-selective air-gap reverse osmosis distillation membranes for desalination, water reuse, and resource recovery under the guidance of Assistant Professor Anthony Straub. Nguyen earned a MS in Environmental Engineering from Arizona State University and a Bachelor's of Science degree in Environmental Science from Vietnam National University. Congratulations, Duong. The AAEES Science Award is given to an individual who is an outstanding performer in the management and implementation of environmental science programs and projects conducted under either public or private auspices. It has demonstrated exemplary professional conduct, has distinguished qualities of personal leadership, originality in devising new management techniques for dealing with environmental issues, and sensitivity and responsiveness to the impact of social and political influences on the conduct of environmental programs. The Science Award was established in 2018, and the 2022 recipient is Professor Anu Ramaswamy. Dr. Ramaswamy is an interdisciplinary environmental engineer and professor at Princeton University, with appointments across India Studies, Civil and Environmental Engineering, and the High Meadows Environmental Institute. She has pioneered sustainable urban system science and knowledge co-production for developing low-carbon, healthy, and equitable cities. Her work explores how 8 key sectors that provide water, energy, food, buildings, mobility, connectivity, waste management, and green public spaces shape human and environmental well-being from local to global scales. Dr. Ramaswamy's work integrates environmental science and engineering, industrial ecology, public health, and public affairs with a human-centered and systems focus. She is the author of more than 100 peer-reviewed articles published in leading journals such as Science, Nature Climate Change, Nature Sustainability, Proceedings of the National Academy of Sciences, Environmental Science and Technology, and Environmental Research Letters. She is the inaugural director of the M.S. Chadha Center for Global India at Princeton University, the lead principal investigator and director of the National Science Foundation supported Sustainable Healthy Cities Network, and serves on the United Nations Environment's International Resource Panel. Congratulations, Professor Ramaswamy. Next is the Brewster Snow Award. The Brewster Snow Award is given annually to recognize an environmental engineering graduate student who has made significant accomplishments in an employment or academic engineering project. The 2022 recipient of this award is Tan Lam. Tan is a graduate from the University of Central Florida with a bachelor's degree in environmental engineering and from the University of South Florida with a master's degree in environmental engineering. Congratulations, Tan. Next, we have the Paul F. Bolos Excellence in Computational Hydraulics and Hydrology Award. This award is given annually to recognize a student whose research contributes to the knowledge pool in the area of computational hydraulics and hydrology. The 2022 recipient of this award is Noemi Vergo-Polon. Noemi obtained a Ph.D. in Civil and Environmental Engineering from Princeton University, and currently she is a postdoctoral research associate at the Princeton University Atmospheric and Ocean Science Program and NOAA's Geophysical Fluid Dynamics Lab, working on Earth system modeling and satellite data assimilation. Congratulations, Noemi. And next, the Academy's most prestigious individual award. The Gordon Maskew Fair Award honors one of the pioneers of environmental engineering, Dean Fair. In addition to his own exemplary career, Dean Fair spawned a living legacy during his lifetime. Those that he taught are now teaching us. Through the Fair Award, the Academy seeks to identify board-certified environmental engineers, board-certified environmental engineering members, and board-certified environmental scientists who have contributed to the status of the environmental engineering or science professions by exemplary professional conduct, recognized achievements in the practice of environmental engineering and science, and significant contributions to the control of the quality of the world's environment. The Gordon Maskew Fair Award was established in 1971, and the 2022 recipient is Dr. Glen T. Daigger. You met Dr. Daigger a few minutes ago. Dr. Daigger is Professor of Engineering Practice at the University of Michigan, and he is an internationally recognized expert in wastewater treatment and water quality management from municipal and industrial systems, with expertise in biological processes. Daigger has served in senior roles for the Water Environment Federation, the American Academy of Environmental Engineers, and the Water Environment Research Foundation. He was a senior vice president and chief technology officer for CH2M Hill, where he worked over 35 years and produced 11 patents on wastewater treatment processes. Dr. Daigger is the president and founder of One Water Solutions, an engineering and innovation firm. He is a member of the National Academy of Engineering, has a Ph.D. in environmental engineering from Purdue University, and a master's and bachelor's degree also from Purdue University. Congratulations, Dr. Daigger, again. Thanks for being with us today. Next up is the Edward J. Cleary Award. The Edward J. Cleary Award is given to an individual who is an outstanding performer in the management of environmental protection enterprises conducted under either public or private auspices, who has demonstrated exemplary professions conduct, personal leadership, originality in devising new environmental protection techniques, and sensitivity and responsiveness to social, economic, and political factors in environmental protection. The Edward J. Cleary Award was established in 1973, and this year's recipient is Dr. Paul F. Bowles. Dr. Bowles is an award-winning business executive and philanthropist, and a world's foremost authority in water resources engineering. He has held senior executive leadership roles in multi-million and multi-billion-dollar companies, including MWH Global, Stantec, Innovize, and Digital Waterworks. Professionally, Dr. Bowles has co-authored 10 authoritative textbooks and over 200 technical papers. He has made a transformative impact in the water industry with innovative solutions for optimizing the resilience and sustainability of water and wastewater infrastructure systems and advancing the development of sustainable water programs. His software became an industry standard worldwide. Paul has been committed to the welfare of young people and led fundraising initiatives that have raised over $100 million for higher education. Among his many involvements, he served as chairman of the board of trustees of the Lebanese American University and the Renee Moad Foundation, and on several nonprofit boards, including Ammon East and A Precious Child. A passionate voice for the next generation of engineers, Paul served as president of AAWRE and ACOPNE, chairman of NAE's Center of Engineering, Ethics, and Society, on the American Society of Civil Engineers Industry Leadership Council, and on advisory boards of many civil and environmental engineering schools where he established student scholarships. Paul was recognized with the Ellis Island Medal of Honor and numerous awards for lifetime achievement, for distinguished community service, for excellence in scholarship, and for excellence in business and profession. He was inducted into the University of Kentucky Hall of Distinction and elected to the NAE and to the grade of Distinguished Member of the American Society of Civil Engineers. Congratulations, Dr. Bowles. The last individual award to be announced today is the Stanley E. Kappe Award. But first, I'd like to introduce Wendy Wert, who is our 2022 Kappe Lecturer and also our Vice President-elect. Welcome, Wendy.
Thank you, Israel. The Academy was founded in 1955 for the principal purpose of serving the public by elevating the standards of our profession. Our founders recognized the need for this network of experts to help address complex environmental challenges. Listening to Glen Daigger, our 2001 Kappe lecturer, take us on a journey of the Clean Water Act was both humbling and empowering. I believe that in our profession, as Dan said, we truly do stand on the shoulders of giants. So I'm going to take you on a brief journey of a few of the mentors who have inspired my career. Next, in my senior engineering year at university, I was asked by Deborah Reinhardt, the 2014 Stanley E. Kappe Award recipient, to help design a reuse distribution system for the city of Sunrise, Florida. I still have our plan to reuse Sunrise's effluent on this floppy disk. Next, the floppy disk may be old technology, but the idea is forward thinking. The need to recycle water has grown throughout my career. Today, two patrons of the Academy, the Metropolitan Water District of Southern California, and my agency, the Los Angeles County Sanitation Districts, have partnered on a monumental recycled water project that has the potential to develop a drought-proof supply for arid Southern California. Next, this slide shows what happens to the water we've treated over the years. Initially, all treated water went to the ocean, as shown in the light blue. In 1962, we began our first recycling plant, and afterwards brought additional recycling plants online. We continue to try to close that gap between the medium blue color and beneficially reuse all of the water from our 10 recycling plants. So our last untapped source is our joint plant, which is the light blue that you see on this slide. Next. So the idea is to, as Glen mentioned, invest in our sustainable future. Wastewater from our homes and businesses will be treated at our joint water pollution control plant, purified at Metropolitan's advanced water treatment plant, and then conveyed through Metropolitan's network to provide a new purified source of water for Southern California. Next. The numbers are impressive. We could provide up to 150 million gallons per day, enough water for 1.5 million people, and become one of the largest programs of its kind in the world. Next, of course, an investment like this takes time. So we're currently in the environmental planning phase. Then we'll move into design and construction in 2024. And then all of you will come out here to Southern California and celebrate with us in 2032 when we go into startup and operations. Next. So from a student design concept for reusing effluent, our profession has made monumental water recycling programs such as this a reality. So I do have, next slide, I do have a room full of experts. So you may be saying to yourself, that takes care of the liquid stream, Wendy. What about the solids? Well, when I took my first consulting job directly after college, my biggest client was Tim Howe, Deputy City Engineer for Los Angeles. Tim won the Academy's Gordon Fair Award in 2008. Tim, as you can see on this slide, had a very hands-on approach to odor testing at our biosolids enhancement program. This program took food waste from the Los Angeles International Airport and put it into digesters. We tried to make the biogas richer, but we couldn't get past that 65% methane content, but we could make more gas. As you can imagine, there were numerous issues with our pilot facility. Next, but now, fast forward 22 years later, and the sanitation districts has the technology and the knowledge to divert food waste to renewable natural gas, which provides an economical source of gas for our vehicles and helps to reduce greenhouse gas emissions in our region. Los Angeles County generates over 21 million tons of waste per year. A portion of that goes to landfills. About a third of that is organic waste. And about half of the organic waste is food waste, which goes to about 1.5 million tons per year and gives us 4,000 tons per day that's thrown away here in Los Angeles County alone. Next. As most of us know, all of us know, greenhouse gas is 23 times more disruptive than carbon dioxide. So in a landfill, this decomposition takes decades, and even in well-controlled landfills like ours, some of the methane leaks into the atmosphere. In a wastewater treatment plant's anaerobic digester, the decomposition takes place in a few weeks and none of the methane leaks. By digesting rather than landfilling food waste, we can reduce greenhouse gases in our atmosphere that can contribute to global climate change. Next, as a result, California has stepped up and passed 2 laws to divert waste from landfills. Senate Bill 1383 requires cities and other jurisdictions to divert organic waste from landfills. The law requires 20% of the edible food that's currently thrown away to be redirected to people in need. The remainder of the organic waste stream can either be diverted to composting or anaerobic digestion. The state began enforcing those requirements just this year in January of 2022. So our food waste recycling program can help our cities and businesses meet those mandates. Next, wastewater treatment plants like our joint water pollution control plant provide an attractive option for recycling food waste because they already have much of that needed infrastructure, like the anaerobic digesters, and facilities to convert the resulting biogas into energy. Using existing facilities avoids significant capital costs as well as the environmental impacts that come from construction. Next, please. So it costs about $3 per gallon of gas equivalent, which is impressive with the current cost of gasoline. This program helped to make the sanitation districts officially carbon neutral. We had worked for decades to get there. So when we did, like all good scientists and engineers, we questioned our results. So we brought in a peer review, that third party, to verify our calculations. Next, it has been an amazing journey. We use science and technology to safely and efficiently take materials that are not wanted and convert them into resources that are. Next, the Kappe Lecture Series was inaugurated by the Academy in 1989 to share the knowledge of today's practitioners with tomorrow's environmental engineers and scientists. Has it succeeded? For me, the resounding answer is yes. I grew up in the Academy, learning from our Kappe lecturers, and I now have this incredible opportunity to contribute to our field. Thank you for the privilege and the honor to serve. I'm looking forward to it. We are honored today to have Jim Moyer from Kappe here with us to say a few words about Stanley Kappe. Jim will also be announcing this year's Kappe Award winner. Welcome, Jim.
Oh, thank you, Wendy. First, I'd like to thank the Academy for allotting the time today to talk on about the heritage of Kappe Associates and really reflect on Stan Kappe's life and the legacy that he left behind. So on behalf of Kappe Associates, I'd also like to thank the Academy for helping preserve Stan Kappe's memory through the Kappe Lecture Series and also through the annual Stanley E. Kappe Award. So we'll start with really just a basic understanding or dialogue about who Kappe is. And I lost my screen here, so 1 second. I apologize. Oh, here we go. So Kappe Associates is a manufacturer's representative company. We serve the Mid-Atlantic region, providing process solutions, mechanical equipment and controls in the water and wastewater treatment and conveyance industry. We currently represent approximately 25 manufacturers, most of whom are global suppliers and world leaders in the treatment industry. Our headquarters are in Frederick, Maryland. We have additional offices in Eastern and Western Pennsylvania, near outside of Philadelphia and also outside of Pittsburgh. From a application standpoint, I'd say our primary focus is municipal applications, with about 20% of our work being industrial and or private entity work. Our Kappe, our company is comprised of outside and inside sales personnel, application engineers, parts and field service personnel, project managers, and internal support staff. And currently we have 22 employees at Kappe Associates. So in regards to and discussing, Stan, in last year in 2021, Kappe celebrated our 75th anniversary. And to talk about Stan here a bit, I put together a few slides. A large portion of the information from these slides was taken from some articles that were published in the Pennsylvania Water Environment Association magazine and also the Chesapeake magazine they ran some articles on our 75th anniversary last year. So prior to founding Kappe, Stan worked for the Chicago Pump Company. He covered Chicago Pump from Maine to Puerto Rico, all the way as far west as the Mississippi River. So he had a very large territory and area to cover. So as you can imagine, this was, tiresome with travel, and eventually he decided to carve out his own area in the Mid-Atlantic area and formed Kappe Associates in 1946, with the first company that he represented being Chicago Pump. And from what I was told, or what I've been told, we were one of the first representative, companies in the area, in the Mid-Atlantic area, to do that. And then other geographic areas and the rep networks kind of developed around the Kappe area, at least here on the eastern side of the United States. So that's how Kappe started. So along with creating and managing a successful business, Stan put a lot of his energy in giving back to the profession that rewarded him so well. And two of the things that Stan was really passionate about were Penn State, where he went to school and graduated in 1930 with a bachelor's degree in sanitary engineering, who had one of the first sanitary engineering programs in the country. And then also his other passion was the academy. So he was an active member and in several national and mid-Atlantic region professional societies. And here are some of the awards that Stan had been recognized for. I won't read them all, but you can see some of the awards that were already mentioned today during the presentation. And you can see the immense amount of volunteer work and giving back to his industry. And he also served as the executive director of the Academy for 10 years, from 1971 to 1981. Most of this slide I may have mentioned before, as I've been kind of going off, not following the slides exactly. So after attending school at Penn State, Stan worked for the PA State Health Department and also the U.S. Corps of Army Engineers for a few years. And then he joined Chicago Pump Company in 1935. And then, like I said, after 10 years of traveling, he formed Kappe Associates in the Maryland, Pennsylvania, southern New Jersey territory area. And then he passed away in 1985. Apologize here, technical difficulty. As part of Stan's ongoing volunteer work with Penn State, he felt it was important for engineers and scientists practitioners to give back to the future generation. So he envisioned a collaboration between the engineers and scientist professionals with the professors and educators. He thought this interaction between them to really go over some of the professional projects and challenges that the professionals faced would better prepare the future generation of engineers and scientists. So this slide here just highlights the Kappe Environmental Laboratories at Penn State. So after Stan's passing, there were various grants and endowments from Stan's estate to both Penn State College of Engineering and the Academy. And I don't actually know all the details of all those arrangements, but at Penn State, they were able to create the Kappe Environmental Laboratories, which still are a large part of their program today. The Academy began the Kappe Lecture Series, which everyone here is aware of, in 1989, and that also continues to this day. So again, Kappe Associates today, our ownership group, is very thankful that the Academy continues to present and do the Kappe Lecture Series to enable professionals to interact with the future generations of environmental engineers and scientists. This slide here, this is Dr. David Kappe. Dr. David Kappe was Stan's son, who took the company over when Stan had passed away. Originally we were headquartered in Rockville, and then we had moved the company to Frederick, Maryland. And this next slide here, this is just a news article of showing the groundbreaking of the new building in Frederick, Maryland, and then the finished facility. And then after, Dr. Kappe had passed away as well, we have a couple other additional CEOs, Mr. Salovich and Fenstermaker, who are still with us. And this slide just kind of represents our current leadership team and the various divisions that we have. So currently, Kappe is in its fourth generation of ownership since Stan founded the company. We're still, going strong after all these years and continue to serve our customers and our clients. And we're involved in a majority of the Mid-Atlantic professional societies, along with AWWA and WEF. And then, kind of in closing here, from Stan, a man's debt to his profession is to help those that follow. So that kind of wraps up what I had. I'd just like to say that I'm personally thankful for our profession and to be part of the academy. And again, I appreciate the time here to remember Stan and help shed some light on the importance of the lecture series and the Kappe Award. If anyone is interested in more information, you can feel free to contact me. I just wanted to say too, from a academy standpoint, like Dan had mentioned, I was introduced to the academy when I had gotten my first consulting engineering job out of college. There were some senior folks in the office who had the DEE designation after their signature, and I was kind of curious. I knew what the PE was, but I was kind of curious as to what the diplomat of environmental engineering was. And I actually was told by the folks there, hey, don't worry about that right now. Let's just learn some stuff, right? Because I was young. Let's say about 11 years ago or 12 years ago, I did become a board certified environmental engineer with the academy, and I'm happy to be part of the academy and be certified. So with that said, the 2022 recipient of the Stanley E. Kappe Award is Dr. Timothy Shea, who's a board certified engineer and a past president of the academy. Congratulations, Dr. Shea.
Good morning, and thank you very much. It's great to return to the Academy and to receive the Kappe Award. This place is the center of professionalism in our fields of environmental engineering and science. Mr. Kappe was the founding executive director, as we just heard, the first of a long line of talented individuals who made the Academy what it is today. I salute that long line, the many friends made along the way, and in particular, Dr. Lilia, Abron, and Dr. Dan Oerther for the dedication to the Academy and the many, many hours it requires. Thank you for this award. I shall cherish it all my days. Thank you.
Thank you, Dr. Shea, and congratulations on the Kappe Award. At this time, we will take a 5-minute intermission so you can stretch your legs, grab a coffee, or maybe send an email. During the break, we will also be displaying some exciting things our members have been up to. So we will resume in 5 minutes. Thank you. Welcome back, everyone. I hope everyone is feeling refreshed and ready to see more awards. At this time, we would like to announce our Excellence in Environmental Engineering and Science Awards. In 1989, the Academy launched the Excellence in Environmental Engineering, renamed in 2014 to Excellence in Environmental Engineering and Science competition to identify the best environmental engineering and science projects in the world. When the environmental engineering began before the Civil War, the challenge was to collect and convey water to growing urban areas. Later, the challenge was to provide sewers to carry away the waste that an ample water supply produced. By the late 1880s, a few pioneering innovators, like Allen Hazen, were engineering methods to purify water and treat wastewater. Abel Wallman perfected reliable disinfection in the 1920s, and before World War II, most of America's citizens had safe drinking water and sound sanitation. The standards for excellence established by those environmental engineering pioneers continue today. In parallel, advances in manufacturing and technology since the 1800s brought along new problems that went ignored for too long. Misuse of chemical pesticides such as DDT, chemical weapons, plastics, and countless other byproducts of advancement went unabated for decades. Through the efforts of professionals like Rachel Carson, a marine scientist working for the U.S. Fish and Wildlife Service in the years before and after World War II, who then turned to writing to chronicle the damage the land, sea, and air were experiencing. Through her testimony to Congress in 1963, she questioned the scope and direction of modern science, and in doing so initiated the contemporary environmental movement that flourishes today. All the entries in this year's competition were judged by an independent panel of experts. The judges' independent evaluations of how well each project addressed the program's 5 criteria are totaled to determine the winners. 1 grand prize is awarded in each category to the highest scoring entry, if applicable. Other high scoring entries in each category are granted honor awards. The highest scoring entry, regardless of category, receives the Academy's Superior Achievement Award for Excellence in Environmental Engineering and Science. First up is our design category. For design and environmental engineering and science, there are 2 awards to present. First, the honor award is presented to Black & Veatch for the design of the Mickelson water recycling plant biosolids and energy recovery facilities in Irvine, California. The engineer in charge for this project was James H. Clark. For the grand prize in the design category, again, the award goes to Black & Veatch as well. The project that earned this grand prize is the Regional San Echo Water B&R project in Elk Grove, California. The engineer in charge for this project was also James Clark. Congratulations, James, and all of Black & Veatch for winning these 2 awards. In the environmental sustainability category, we will be presenting 1 award. The grand prize in the environmental sustainability category is presented to HDR for the C44 Reservoir and Stormwater Treatment Area project in Florida. The engineer in charge for this project was Susan Ray. Congratulations, Susan, and all of HDR. In the industrial waste category, we will be presenting 1 award. An honor award for industrial waste goes to Stanley Consultants for their Muscatine Organic Waste Recycling Center project in Muscatine, Iowa. The engineer in charge on this project was Jay Brady. Congratulations to you, Jay, and everyone at Stanley Consultants for this award. In the operations management category, we will be presenting 1 award. An honor award for operations management goes to Orange County Sanitation District for their optimized odor control and cleaning and sewer system project in Fountain Valley, California. The person in charge on this project was Jeffrey Brown. Congrats to you, Jeffrey, and all of the folks at Orange County Sanitation District. In the small projects category, we will be presenting 1 award. An honor award for small projects goes to Stanley Consultants for their Kent Park Watershed and Lake Restoration project in Oxford, Iowa. The engineer in charge on this project was Wyatt McCain. Congrats to you, Wyatt, and everyone at Stanley Consultants. For University Research in Environmental Engineering Science, there's 1 award to present today. The Grand Prize Award is presented to Stanford University for their research on the efficient anaerobic treatment of domestic wastewater, enabling net energy production and low-waste biosolids in Stanford, California. The professor in charge for this project was Craig Criddle. Congratulations, Professor Criddle, and to your team at Stanford University. Now, it is my pleasure to introduce Dr. Lilia Abron, our 2021 Academy President. Dr. Abron will be announcing the Superior Achievement Award. Dr. Abron.
Thank you, Israel. I'm so happy to be with all of my dear friends today, be it virtual. It's still such an honor to be with you and celebrate. I call this award ceremony our prom. So this is our big day, and we're so happy to celebrate. Glen, I learned a lot. Thank you for the history lesson. And Tim, is so great to, even while virtual, to still see you in person virtually. So thank you for this wonderful day. It is my pleasure now to introduce the winner of the Superior Achievement Award. This is such an exciting award to win. The company that I work for won this award in 2012. So I know what an honor and the excitement that this award brings. So congratulations. This award this year is presented to HydroGeoLogic for the innovative use of in situ treatment technologies at Joint Base Andrews in Brandywine, Maryland. The engineer in charge for this project is Robert Bird. Congratulations, Robert, and everyone at HydroGeoLogic. I know you're happy. If we had a horn, we'd blow it, and we're clapping our hands. Congratulations for a job well done. Here with us today to discuss this project is Ken Cottrell, Principal Project Manager at HydroGeoLogic. The information on Ken is here, but basically, project manager, been with 30 years experience, a bachelor's and master's in earth science with honors in liberal studies from Adelphi University. He's managed environmental restoration efforts at this Brandywine site for 16 years through the completion of the final remedy. A long time, and that's what it takes to earn this award. Thank you so very much. Ken, please tell us about your project. Thank you very much.
Thank you, Lilia. Thanks for that introduction. I just want to open with, we're a very illustrious company, and HCL is honored to receive this award from AAEES. We're proud of our project, and maybe you'll sense that as I share it with the group, and its use of innovative technologies that really advanced our industry's ability to remediate groundwater contamination in challenging environments. I'm going to shut my camera off to save some bandwidth, and I think we can hop right into the presentation. Okay, that's just an overview of the site. So immediately you're going to see some logistical challenges that we are going to talk about. Dr. Daigger earlier spoke on how, the maturation of regulations over time. We attended a conference last week that talked about innovations in remedial technologies over the past 30 years. And as mentioned, we've been involved with this site for over 15 years. And I think HCL was really privileged to manage and direct environmental efforts at this site. It's a great site, as you'll see, with a lot of opportunity for that innovation that we talk about. So just to run through the presentation, this is my introduction, and then we'll sort of get right into it. We're going to talk about interim remedies, how they led to the use of high-resolution site character techniques, how we applied the outcome of that to the final remedy, and then the final in situ treatment thermal remedy. So just a few details on the site. Depth of groundwater at Brandywine, 2 to 15 feet. The overburden lithology, sand, gravel, silt and clay lenses. The kicker here is really the lower permeability unit, the Calvert Formation, which is present anywhere from 16 to 38 feet below ground surface. So what's a DRMO, you might ask? That stands for Defense Reutilization and Marketing Office. Essentially, it was a warehouse that took any surplus or off-spec materials from nearby DoD installations in the DC area. Anything from PCB transformers that nobody else wanted to off-spec or waste chemicals. So one might imagine that during its operational history, there were a few releases to the environment. So those releases led to, among other things, an approximately 20-acre plume of trichloroethane, which extended from the site into a residential area. Probably the easiest thing I can do is walk through this. This was actually a poster board that we would use at public meetings to describe efforts at Brandywine. So in the upper left-hand corner, well, the interim record of decision was signed in 2006. That was for the interim remedies. And we talk now, when we talk about innovation, we talk about coupled remedies. And this was a coupled remedy of pump and treat to hydraulically control a source area, which back then was not really well understood. And then injections in what we'll call the distal plume, the 20-acre plume, for bioremediation. So in the upper left-hand corner, after we got this contract, we did some pre-design investigation activities and really nailed down the nature and extent of the TCE plume. So it's pretty significant, actually about 23 acres in total. HDL designed, constructed, operated the pump and treat system. It went fully operational in 2008. In the bottom left-hand corner, you can look at the construction. On the left, we basically dug a recovery trench, keyed into that underlying clay layer, and it was about 220 feet long with recovery wells on either end of the trench to achieve hydraulic control. So that was that part of the remedy. We operated it for 5 years, pumped 12.5 million gallons of groundwater, and removed 90 pounds of VOCs, which really isn't a lot when you think about it. 90 pounds of VOCs, because of their density, it's about a bucketful. It's a big bucket, but it's still just a bucketful. The other part of the remedy was injections. So from 2008 to 2014, over 3 or 4 injection events, we injected in over or approximately 2,000 points to stimulate microbial degradation of TCE. One of the innovations that was talked about at the conference last week was to bio-augment or not. We did back then during the very first injection. Injected DHC, bacteria that uses TCE to respire, and they ate it up because, as you can see in the upper right-hand side, the plume was reduced to about 1.5 acres. So it was really a tremendous success. 92% reduction in plume size. Now we're not talking about mass, but we are talking about plume size from 20 acres to 1.5 acres. And really, we got it out of the residential area, and it was limited to the area that was under hydraulic control of the pump and treat system. So after 5 years, again, 90 pounds in 5 years, not a whole lot, and we were seeing diminishing returns from the pump and treat system. And so, I like to say remediation is really the final phase of site characterization, because as you clean up, sources start to reveal themselves that you may not have been aware of before. So our efforts shifted to source characterization. So I'll talk a little bit about the high resolution site characterization that we did. Back to fusion years ago was not a thing. It became a thing as we were investigating and remediating Brandywine. So as sites matured, we still had these persistent sources, and we suspected that underlying clay contained a significant mass of TCE that was back diffusing into the Brandywine formation. So how do we prove that? We used a combination of high resolution site characterization tools to investigate that. Is membrane interface probe. There's a heated probe at the end of a geoprobe drill stem. It's kind of the center picture. You can see drilling between the railroad tracks, which is where part of where the source was suspected. Heated probe volatilizes contaminants in the soil as it's advanced. You can see an orange tube. They're brought up with a carrier gas, and on the right-hand side, there's several detectors within that van that are analyzing the VOCs as they come up. So it gives you a qualitative measure of concentration in real time. The other thing we used were something called passive flux meters, and I don't know if folks are familiar with passive diffusion bag samplers, but basically they're passive devices that contain carbon and a tracer. The tracer, you put the PFM in and you take it out, and you look at how much tracer you've lost. That gives you a sense of Darcy velocity in the aquifer. And the carbon is absorbing VOCs while it's down there. So doing some fancy math, you can calculate the mass flux per unit volume of aquifer of contaminants. So what does the MIP give you? The MIP gives you what we really needed, was the source area geometry. So red is bad. Red is the mass of TCE in the underlying aquitard, which you can see the upper left is a measure of conductivity, the conductivity probe on the MIP. So from these drawings, we can tell where the mass is and what strata it's in, and it's in the clay. So those are our conclusions. The PFM data revealed sort of a classic back diffusion signature because we straddled those PFMs with the clay Brandywine formation interface. So you could really see where the contaminants were coming off the clay and into the Brandywine formation. And of course, the MIP investigation, as I showed in the previous slide, gave us the nature and extent. It also assisted us in establishing a kind of a rudimentary mass estimate, which you need for any remedial design. So our conclusions, again, bulk of the mass was present in the low permeability layer. So how do we apply that to a remedy? Well, in situ treatment, any kind of in situ treatment requires contact. Dig and haul under those railroad tracks was not something the railroad was particularly enamored with. So we were looking at an in situ treatment technology. Because most of them, like ISCO or even bio, require contact, we really did have a challenge with this tight underlying clay. That led us to go with a thermal remedy because electrical resistance heating or most thermal remedies in general are not limited by soil heterogeneity, and clay is a wonderful conductor of electricity. So what is ERH? Kind of simply, what we do is we install electrodes into the subsurface and apply power to them. We apply a current. That current moves among the electrodes, and the natural resistance of the strata creates heat. And we can bring the subsurface temperature up to the boiling point of water, 100 degrees C. Contaminants, TCE boiling point is about 85 degrees C, but if you get into the chemistry of things, the compounds form heteroazeotropes. They actually boil at a less effective temperature, which also works very well for thermal. You can actually boil off contaminants that under standard temperature and pressure have a boiling point above 100 degrees C. What we do is then we boil off, we capture the vapor. So there's a vapor recovery piping system in the vadostone, and that's treated by carbon. We have knockout pots to knock out condensate, and we treat everything coming out from the subsurface with carbon and discharge it to the atmosphere. So permanent solution. What did final ERH remedy at Brandywine look like? Well, it looks an awful lot like those pictures where we're trying to cover what was red in the source area geometry. It was just shy of an acre, around 40 feet deep, so about 49,000 cubic yards. I didn't mention earlier, 1,4-dichlorobenzene. There was also a shallow plume of 1,4-dichlorobenzene that we also had to treat with thermal. And I think the boiling point of that is like 110 or 120 degrees C, but again, because of the heteroazeotrope properties, we were able to boil that off as well. Constraints, we're going to get into constraints, but just a little bit more of the design. What I'm showing here, we had 43 board electric pairs and 58 sheet pile electrodes. The sheet pile electrodes are kind of those long rectangles. We love sheet pile electrodes. The more surface area on an electrode, the better the ability to get energy into the ground. So we really like those, and they go in very easily. Board electrode pairs, when I start getting into constraints on the next slide, you'll see some pictures. I'll explain the why on those. 17 temperature monitoring points throughout the treatment volume. They measure temperature at 5-foot increments vertically, and of course 17 laterally, so that we can look at heating across the whole volume and adjust our power delivery as necessary. Pretty big area. We had 2 equipment compounds, one on the east side of the tracks, one on the west side of the tracks, although that didn't preclude us from having to go under the tracks to install some infrastructure. Technical and logistical challenges. Overhead power lines. So on the left, you can see a sheet pile electrode going in, and I think if it took 5 minutes to get a sheet pile electrode in, it took a lot. We were, I think, averaging 3 or 4 minutes a sheet pile. So we love sheet pile electrodes, and you can see we're putting one right in the middle of Cherry Tree Crossing Road, a public road. We can't do that because that's about 35 feet up. You can't do that under electrical lines, as you'll see in the right-hand picture, or very close to the CSX tracks. They did not want us installing sheet piles next to their tracks. Hence the board electrodes. And they're board electrode pairs because, again, it's surface area. We're trying to maximize our surface area to optimize our power delivery. Just more photos of construction, pictures, worth 1,000 words. You can see on the bottom left, that is some of the jack and bore conduits that we had to install under the railroad tracks to meet CSX engineering requirements, essentially. They have specs for pipeline corridors and things like that we had to follow. And I think you can just get a sense of, logistically, some of the challenges that the railroad posed. I will brag and say that this was the first in situ thermal treatment remedy performed under active railroad tracks. Because of that dubious distinction, CSX had a lot to say about how we monitored their tracks. I think a big fear of thermal is subsidence, and that fear is generally unfounded. There are certain areas where you should not do thermal. If you're in an area with peat, where peat could be desiccated, is one example. But really, CSX still wanted their tracks monitored. I just saw a question flash up. Yes, we did angle some electrodes under the tracks because we needed treatment under the tracks, and the heat under an ERH remedy, heat does not really propagate that far in the subsurface. We had an extraordinarily elaborate track monitoring system. The center photo, it's very hard to see, but we affixed an automated total station on their signal. What you can see on the right-hand side is a prism, and we installed probably close to 100 prisms on the rails. And periodically, that total station would look out over the area and survey those prisms and basically calculate if there had been any movement on the rails. It's kind of like the Lord of the Rings, the Eye of Sauron, just kind of scanning the environment. So what you see on the bottom is some of the track monitoring data and diurnal fluctuations throughout the day. Federal Railway Administration has very specific tolerances on track movement, and we did not approach any of those tolerances during the entire time we were heating. CSX probably has its own problems environmentally, legacy sites, and I have no doubt they are using this data to hopefully further their program. Just a picture or two of operations. Bottom left, we're groundwater sampling. You have to do something called hot groundwater sampling. You have to run the groundwater through a closed loop system in an ice bath because it's very hot during your thermal remedy. It's been approved by regulatory agencies as the method to sample groundwater during ERH. There's also an SOP to do hot sampling in soil. And I just want to illustrate on the right, you'll see a poly plenum. That's to ensure we have vapor recovery. There are also cameras and motion sensors that if there was an incursion into the electrode field, the system would automatically shut off from a health and safety perspective. So success. We operated the system for 206 days, which is actually a pretty long time given the mass that we had down there to operate. One of our contract requirements, which is odd for a thermal remedy, I don't recommend it. We should really be looking at mass reduction, but we were to achieve MCLs for TCE and 1,4-dichlorobenzene, and we did. There were 1 or 2 recalcitrant wells, which is why we had to operate for 206 days. But again, we optimize power delivery the way it's designed and constructed. We can shut off power delivery to different areas of the electrode field, and that's a good cost-saving measure and optimization measure. Bottom line, 97.2% reduction in TCE and 99.5% reduction in 1,4-dichlorobenzene. And as I mentioned before, we achieved MCLs throughout the treatment area and 1,700 pounds of contaminant mass removed, which was more than our rudimentary mass estimate. So that's all. I'm really honored that HDL was able to share this project with you. And again, thank you for the award.
Thank you, Ken. We appreciate your time with us today. And again, congratulations on this award. The last part of our event today is announcing the Communication Award. Ladies and gentlemen, we are in a new era. As the costs and scopes of environmental engineering and science projects increase, effectively educating the public has become increasingly important. This is the basis for the Environmental Communications Award. We have one environmental award to present today. The grand prize is presented to Los Angeles County Sanitation District for communicating during an emergency, our response to a major sewer spill. Congratulations to Los Angeles County Sanitation Districts. Now, we're going to take a moment to hear from our new Executive Director, Ilyse Shapiro. Good afternoon, Ilyse.
Thanks, Israel. Hello, I'm Ilyse Shapiro, the new Executive Director of AAEES. I just wanted to take a few moments of your time to thank you all for attending this year's award ceremony. We are so proud of you, so proud of everyone who took part in the event, and I offer a special congratulations to all of the award winners. I also wanted to update you on a few new happenings at AAEES. First, within a few weeks, we will have our new website up and running. This is a long overdue project. We thank those members who offered their feedback on a recently distributed survey about updating the site, as well as a special thank you to our beta testers. Second, we are in the process of developing and updating several programs that take everyone under our umbrella into consideration. High schoolers, college students, emerging leaders, certificate programs for young professionals, micro-credentialing for those who are considered post-bac, and programs for members seeking certification. Lastly, we are in the process of creating a few new committees: a Government Affairs Committee, a K-12 Committee, and an International Relations Committee. If you have any interest in joining any of these committees or would like your voice heard with regard to the new programs, please feel free to call me at the office or email me. Thank you and enjoy the rest of your day.
Thank you so much, Ilyse. The Academy is so happy to have you on board. We have one more exciting program to share with you today. The Academy is proud to introduce the AAEES 40 Under 40 Recognition Program. This program was introduced to recognize talented individuals who have, either personally or as part of a team, been responsible for helping to advance the fields of environmental science or environmental engineering in a demonstrable way within the last 12 months. Congratulations to all the 2022 40 Under 40 honorees you see listed on this slide. You truly are making a difference in this industry. Make sure to follow our social media channels as we will be showcasing these honorees in the coming months. In conclusion, Dr. David Vaccari, President-elect of the Academy, would like to say a few words. David?
Yes, thanks, Israel. And could you go to the next slide? There should be something there that I will speak about. While we're waiting for that, I just want to add my congratulations to all our award winners and my appreciation for the speakers who talked about the history. I love learning the history. I think it's important for us to know where we come from. And the other thing I want to mention was I want to thank, as president-elect of the Academy, I want to thank my two immediate predecessors, past President Lilia Abron and the current president, Dan Oerther, who, as being on the executive committee with them, I'm learning a lot about leadership, and I appreciate the lessons I've learned from them. Marisa, are you able to go to the next slide? There we go. Yeah. Thank you. So I wanted to use this opportunity to take a couple minutes to highlight some changes to the Academy's vision, mission, and objectives that were developed together with the Planning Committee and the Strategic Planning Work Group and was approved by the Board of Trustees of the Academy in November. So these changes only reinforce what the Academy has been doing for years, but orients our objectives towards the Academy's constituents. So starting with our vision statement, this is a brief statement of what we are, which is that we're about learning and excellence in environmental engineering and science. And then there is the mission statement, which encapsulates what we do. And the mission of the Academy is to promote continual improvement in environmental engineering and science, education, and practice. And underlying that are our four objectives, which we have aligned with our constituencies and our activities to clarify what we do and who we do it for. So those constituencies and their associated objectives and activities are, first of all, the pre-professionals. Those are the student members, the student chapters, and even K through 12 and college level students who are the future of the Academy. We want to create pathways for them. We want to create information for them on environmental careers that will guide them in their professional choices. The next category is the professionals, and the objective is to provide continuing education for all environmental engineering and science professionals. And that's where our webinars and workshops and conferences come into play. Continuing education is something that we all benefit from and furthers our mission. And the professionals, this fits with a category of what we call the membership category, that anyone with a science and engineering background can join the Academy as a member and participate in our activities as that member. But then that leads to the third constituency, which is the advanced professional, and those are our board certified members. Those have experience and training and have demonstrated that they are at the pinnacle of the profession, and that they have specialized within environmental engineering and science. And that we offer the specialty certification and awards. And we think that the professionals, eventually the goal would be to move them towards becoming board certified professionals. Finally, there is the public is one of our constituencies, and that's basically everybody else. And this has always been one of our objectives of the Academy, is to harness the technical expertise of our members to advise decision makers and the public on the use of environmental engineering and science to improve and maintain the environment. So these are our ultimate beneficiaries. So we think the Academy can increase its role in this direction. You heard Ilyse Shapiro talk about our new committee for legislative activities. That's one way we can start reaching out to influence legislation and also make policy papers and inform the public about areas that are important to us. So to conclude, I just hope that by seeing our vision, mission, and objectives organized this way, each of us can see how we fit in, how we individually can contribute to the Academy's mission, and how we can also benefit from the Academy's activities, and to feel that the mission of the Academy really could and should be something that all of us can embrace. So that's it. Thank you again, and thanks again, Israel, for giving me the opportunity to speak to this terrific group. And I'll hand it back to you. Thanks.
Thank you so much, Dr. Vaccari. And thank you all for spending some time with us today. A recording of this event will be available tomorrow on our website, and PDH certificates will be emailed over the next couple of weeks. On behalf of the Academy, its leaders and members, I thank you for your attendance today. Enjoy your afternoon.